Hello, dear students in grade 9. This is our first mathematics video. Revising in this video the most important concepts or rules we studied together in calculations of numbers. This will be our first lesson in our 9th math book. The title of this lesson is Rational and Irrational Numbers. Concept number 1, we will define numbers. We have learned many numbers in math, so these numbers are classified to natural numbers, whole numbers, integers, decimal numbers, and the prime numbers. Of course, natural numbers are the positive numbers from 1 until all the positive numbers end. A whole number starts from 0 and all the positive numbers. Integers are 0, positive numbers, and negative numbers. Decimal numbers are the numbers having a decimal point in between. They can be positive or negative. Prime numbers are the numbers that are divisible only by 1 and themselves. 2, 3, 5, 7, etc. Rational numbers in math can be written as fractions. For example, the natural number 5, we can write it 5 over 1. It's a fraction. Negative 14 over 1. 3.13 can be written as a decimal fraction. 313 over 100. Okay, now radical 16, it can be written as 4 over 1. How? 16 can be simplified as a radicand into 4 square. So it can be written as a fraction 4 over 1. Irrational numbers, these numbers can never be written as fractions, like the pi in math, which we use in the circles, which is 3.14, etc. It cannot be written as a fraction or radical 7. A periodic number has repeated decimal parts in it, like the 0.666, etc., 13.8282. These are periodic numbers. Now we move to the concept, the third one, which talks about powers. What are powers in math? A power is a way to express repeated multiplication. The notation of power, any number written as a power, it's written as a to the power n. So where a is a base and n is the exponent. For example, 3 to the power 7, 10 to the power 4, 9 to the power 2, which is read 9 squared. If we have a power and we want to calculate its value, for example, a to the power n, we multiply a by itself n times. 4 cube equal, we multiply 4 by itself 3 times, 4 times 4 times 4. Now, we move to the next concept. Now we'll talk about rules of powers. To calculate powers, we have different rules. A to the power 0 is always 1. So any power having exponent 0 always give you 1. 42 to the power 0 equal 1. A to the power 1 always equal A, as if I'm multiplying A by itself 1 time. 11 to the power 1 equal 11. 1 to the power n equal 1. For example, 1 to the power 39 equal 1, as if I'm multiplying 1 by itself 39 times. 0 to the power n equals 0. So 0 to the power 13, 0 times 0 times 0 times 0, it gives you 0. The first rule of power is a to the power n times a to the power m. If I am multiplying two powers having same bases, different exponents, we keep the base and we add the exponents. For example, 13 to the power 6 times 13 squared equals 13 to the power, we add 16 plus 2, it's 8. So it is 13 to the power 8. A times B, all of it to the power n. Since inside the parentheses we have multiplication of two numbers, the exponent outside can be given to both numbers. So the rule is A to the power n times B to the power n. For example, 4 times 2, all of it to the power 5. 5 is given to 4, so we get 4 to the power 5 times 2 to the power 5. Now, the rule power of power, a to the power n, all of it to the power m. So we keep the base a and we multiply both exponents n times m. A to the power 5, all of it cube, is a to the power 5 times 3 is 15. Now, if we are dividing a fraction having different numerator and denominator, a over b, all of it to the power n, also in case of division of fractions the exponent is given to both values. So a to the power n over b to the power n. 7 over 3, all of it to the power 6. It's 7 to the power 6 over 3 to the power 6. Now, if I'm talking about powers having negative exponent, always the negative exponent should be changed into positive. A to the power negative n. Here, the fraction a to the power negative n over 1. So I get the inverse of this fraction or the reciprocal of this fraction. I flip it. It becomes 1 over a to the power n. Always keep in mind to change a negative exponent to a positive exponent, we take the value of the power, all the power, we take it from the numerator to the denominator or from the denominator to the numerator. So 10 to the power negative 5 is 10 to the power negative 5 over 1. So the fraction becomes 1 over 10 to the power 5. Now we have a to the power n over a to the power m. I'm dividing two powers having same base, different exponents. So it's a to the power n minus m. Now, if you can see here, the negative exponent is in the denominator. To change it to positive, I should take it to the numerator. So it becomes a to the power n. Now, we'll talk about powers having a negative base. If I have a power with a negative base, I always look at the exponent. If my exponent is even, so my answer will be a to the power n. It will be positive. If my exponent is odd, my answer will be negative, minus a to the power n. For example, minus 3 to the power 4, since 4 is even, so my answer will be 81. 3 to the power 4, which is 81. Minus 3 cube, the exponent 3 is odd, so my answer will be negative 3 cube, which is negative 27. Talking about powers of 10, these powers always have base 10. The notation is 10 to the power n. This exponent n, it can be positive or negative. If it is positive, so I will get 10 to the power 5, for example. I take from the base 1 and I add 5 zeros as the exponent. Now, in case of the negative exponent power of 10, 10 to the power negative 3, I take 1 and I move the point in the number to the left since I have a negative exponent. Talking about reciprocals and opposites of two numbers, the reciprocal of a number is its inverse. We flip the number or the fraction. For example, 2 over 3, its inverse or reciprocal is 3 over 2. 5, its reciprocal is, it's 5 over 1, so the reciprocal will be 1 over 5. The opposite of a number, the opposite of a positive number is negative, and the opposite of a negative number is positive. Opposite of 5 is negative 5, opposite of negative 9 is 9. We move now to the concept of fraction. The fraction in math, we write it as a numerator over denominator. As fractions, we have reducible ones and irreducible ones. Reducible fractions can be simplified or made smaller. For example, 25 over 15. If we have a fraction 25 over 15, we can simplify both the numerator and denominator by 5. 25 divided by 5 is 5, and 15 divided by 5 is 3. Always to simplify a fraction, we divide the numerator and denominator by the same number. Irreducible fractions cannot be simplified. For example, 11 over 6, there is no common factor between both the numerator and denominator to divide the fraction by this factor. Always keep in mind, if we have a fraction, the numerator and denominator are consecutive or successive. Numbers coming after each other, this fraction is always irreducible. In a fraction with the numerator 1, 1 over 4, 1 over 3, 1 over 6, always this fraction is irreducible. Operations on fractions. All fractions can be added, multiplied, subtracted, or divided. So if we have addition or subtraction of fractions, always we look at the denominator. If we have like fractions having same denominators, we keep the denominators, we add or subtract the numerators to get our answer. Always our answer should be irreducible. Now, if we have addition or subtraction of unlike fractions, we should change them into like. So 2 over 7 plus 1 over 3, these are unlike fractions. To change them into like, we multiply the first fraction by the second denominator, and the second fraction by the first denominator. They become like. After that, we continue. Multiplication of fractions, always we multiply numerator times the numerator over denominator times denominator. Here we simplify the factors, then we get our answer. Now, talking about division of two fractions, here we have steps we should apply. We keep the first fraction as it is, we change division into multiplication, and we find the reciprocal of the second fraction. Now we go back to the steps of multiplication. Compound fractions in math is a fraction written as a fraction 1 over fraction 2. Fraction 1 has a numerator and denominator. Fraction 2 has a numerator and denominator. Always a compound fraction should be written as a simple fraction. How do we change it to a simple fraction? We always multiply numerator 1 by denominator 2 over denominator 1 times the numerator 2. As we say, far times far over near times near. For example, 7 over 15 over 8 over 25. We multiply 7 times 25 over 15 times 8. We simplify the fraction if we can simplify. Finally, I will remind you of a number written in scientific notation. To write a number in scientific notation, we should write it in the form A times 10 to the power n, where A is a number between 1 and 10, and 10 to the power n is a power of 10, where n is an integer. This n can be positive or negative. For example, this number, we should write it in scientific notation. I should write it a number between 1 and 10. So I should put the point here. So it's 1.4 times. To write the power of 10, we count the zeros and we see how much did we move the point to get a number between 1 and 10. So it's 10 to the power 8. Now, if we have a decimal number, it's the same. But since it's a decimal number, we write a negative power of 10. This was what we should revise starting grade 9. Please watch this video well, and if you have any question or any concern, just ask me. Thank you.